So, good morning, everyone. I'm M.Yogadharani, working as Assistant Professor in Department of Computer Science Engineering at SPS College of Technology. Today, our classmate Badma is going to take seminar on optimizing classifier. It is an important topic. Listen, everyone.
Hello everyone, I am Badma. Now I am going to make a seminar on applied machine learning on the topic of optimizing classifiers. First of all, classifier is a label in the machine learning which classifies into two types, yes or no type. By defining the classifier, we need to evaluate how good the classifier is. And the good means how it's performed in the real-time application. By this, we can follow some procedures. First, we need to classify what is confusion matrix. Depends upon the confusion matrix, the classifiers uses matrices. This confusion matrix is used for evaluation of the matrices. First time, a classifier is a label. All is clear that once we train the class, we need to evaluate how good the class performance is. For that, we use metrics. The metrics depends upon the confusion matrix. This is actual positive, actual negative, predicted positive, predicted negative. This is the real scenario. This is actually positive from the data set given. With predicted positive and predicted negative is the data that our model predicts. This is a predicted one, this is the actual one. By using this matrix, we can calculate accuracy, precision, recall, FM score, etc. For this case, we take only three: accuracy, precision, recall. The formula is true positive plus true negative divided by true positive, false positive, false negative, true negative. Like the formula is a predefined one. After defining the formulas, we need to optimize the classifier to perform well. For that, we need to evaluation the metrics. The evaluation metrics are of 5 types: threshold tuning, resampling fetching, cost sensitive model selection, hypermeter tuning. First of all, can I tell the real-time example of how metrics are important in our classifier? For example, email spam detection. 99 upon 100 emails, 99 emails are spam. One email is non-spam, means that model we trained predicted the accuracy till 100%. First, 1% is one mail is not a spam, another 99 mail is spam. So there accuracy leads to mislead. Likewise, in the medical diagnosis, cancer patients predicting how many patients are cancer, the accuracy will mislead. So that we will use precision for the better performance. For threshold tuning, the default threshold tuning is 0.5. If the data are having minority or majority data, then we tune the threshold to if the probability is greater than 0.5, we less than the threshold default point to 0.3 or 0.4. If the probability we predicted is more than the threshold point, that means the threshold point is 0.5. If the probability we predicted is greater than the threshold point, we need to increase the threshold point to increase the threshold point to 0.6 or 0.7. Only we have limits to change, increase or decrease upon 0.2 points. Resampling technique is if the another one example, if the branch transactions are upon 1000 transactions, 900 transactions are completed successfully, but 100 transactions failed. The model is trained that predict 99% accuracy. But in real scenario, 100 transactions failed. At that time, recall is more important. And then resampling technique is also more important. What we need to feed to the model is we need to feed more data that the transaction is also failed. Because once we train a model, just evaluate how many or how many bags. In this scenario, how many transactions are successful and how many transactions are failed. So that scenario, from all the data, that the failure of transaction rate is so low. So the accuracy is misleading. We need to see more failure transaction. Upon 1,000 transaction, extended to 2,000 transactions, and we need to feed how many transactions are successfully done and how many transactions are not successfully done. At the time that accuracy is also good, we can predict good ones. Like this, each of this types has its evaluation calculations.
So what are the measures you going to evaluate in classifier? Otherwise, I think if I am familiar with what are the matrices in regression, can anyone?
We actually teach square ask.
Okay. Now guys are familiar with our classifier. So thank you.